Good morning dear students. Today let's study about forging process. Forging process is primarily a metal forming process. By using hammers or presses and applying compressive loads on the materials, a shape change process occurs. Such process is known as forging process. What are the main uses of forging process, or what are the typical parts that can be made by forging process? Forging process are used to make crankshaft and connecting rods for engines. They are used to make hand tools. They are used to make many structural components for machineries, and it is also used for making transportation equipments. Now let's look what are the classifications of forging operations. Mainly, forging operation is classified into two. They are impact forging and press forging process. In impact forging, a forged hammer is used where it applies an impact load on the material, whereas in press forging, gradual pressure is applied on the material using various type of presses. Now let's look another classification of forging operation. Forging operation is also classified as cold forging and hot forging. As we all know, hot forging or warm forging operation takes place at elevated temperatures. It increases the ductility of the material, whereas a cold forging occurs at normal room temperature. The main advantage of cold forging process is that it increases the strength that results due to strain hardening process. In cold forging, as we told earlier, it is done at room temperature, and the hot forging is done at elevated temperature. Because of the higher strength of material, cold forging requires greater forces, and the workpiece materials must have sufficient ductility at room temperature. Cold forged parts have good surface finish and dimensional accuracies. Now let's look what are the advantages of forged parts over cast parts. In forging, large grains are broken to small size, which is desirable for optimum mechanical properties. In casting, the grains remains the same. In forged parts, grain flow occurs to forged shape and exhibit directional properties like toughness and strength. The ability to absorb shock in case of casted parts is minimum, but for forged parts is much higher. So in summary, we can understand that due to the change in the grain shape, the mechanical properties and toughness and strength of forged part increases over the casted parts. What are the classifications of forging process? The forging process can be classified based on equipments and based on process. By equipments, it can be classified into hammer forging or drop hammer forging, or as press forging. By process, it's classified into open die forging and closed die forging. The various types of presses that are used are mechanical presses, screw presses, and hydraulic presses. Also for impact forging, hammers are used. In impact forging, the potential energy of the ram causes the shape change. The speed can be very high. Also, multiple blows may be needed for a shape change. Now let's look in detail on mechanical presses, screw presses, and hydraulic presses. In mechanical presses, they usually work on crank and knuckle joint. The first figure shows a crank arrangement and the second figure shows the knuckle joint arrangement. In both these arrangements, the downward movement of the ram causes the forging operation to happen. The third figure shows a screw press where the energy is from a flywheel. The load is transmitted through a vertical screw as shown in figure. And the final figure shows a hydraulic presses. In hydraulic presses, large amount of energy can be applied for forging. The hydraulic energy is applied for the shape changing process. The first operation is upsetting operation. Let's look what's an upsetting operation. Upsetting is carried out to increase the thickness or diameter of a material and to reduce the length. For example, forming a bolt head. In the figure, we can see if we want to increase the diameter at a particular region, we have to heat only that particular region. The other region remains cold. Then, holding with a tongue and applying force, the particular region thickness increases or the diameter increases and reduces its length. This is an upsetting operation. Next is a drawing down operation. In drawing down operation, it is used to reduce the thickness of a bar and increase the length, whereas in upsetting operation, it was reducing the length and increasing the thickness. It is just opposite to the upsetting operation. This operation is carried out by hammering the hot workpiece, keeping it on anvil and holding it by a suitable tongue. Next is fullering operation. In fullering operation, it is used to reduce the cross-sectional area of a portion of a stock. It is used with the help of a fullering tool. The heated stock is placed on the fuller fixed on the anvil. A fuller is put over the stock and hammering is done. It reduces the cross-section of the job at the required point. So, in fullering, it is used to reduce the cross-sectional area at a particular portion of the stock. Next is an edging operation. It is used to shape the ends of bars and to gather the metal. In the first figure, you can see the stock is a flat rectangular shape and it is placed inside a die to be altered to a new shape. While applying the force, the material fills the die cavity and causes the edging operation to happen. Next is bending operation. The part to be bent is heated to plastic form and then hammered by placing it on the anvil side. In the figure, we can see the stock is heated and kept on the anvil and applied the force, and the bending process happens. By moving forward, more bending can happen on the stock workpiece.